Daily summary. In this lesson, we solve equations that include algebraic fractions. The second sentence should not be there. I'll cross it off. Number one, when solving equations, once we get all the fractions to have a common denominator, by completing them just like we did before, we're going to multiply both sides of the equation by the common denominator. Today is a fundamentally different day, different kind of day than the last 3 days. So we spent 3 days playing with algebraic fractions. And on the first day, we simplified them and we multiplied them and divided them. And then on the last 2 days, we added them and subtracted them. Today, we're going to be solving equations that include algebraic fractions. And so for the last 3 classes, answers have been things with x's in them. But today the answer is going to be stuff like x equals 5. It's going to be numbers because we're solving equations. One thing, it's mandatory to check your answers. We're going to see why in just a second. We really haven't stressed that idea of checking your answers when solving equations this semester, but for these kinds of equations, you just have to do it. You can read through part A later on. I just want to skip right down to part B. We're going to solve this equation right here. 2 plus 4 over x minus 2 equals 8 over x squared minus 2x. Everything's written out there, but I'd rather feel like we're doing something. So can you find some blank space? Maybe the page before has some room for us to do this, so we're not just reading what's already filled in. Anybody find a page with some little bit of blank space? Yeah, that's good there. 234 has blank space on it. Okay, so just copy the equation wherever you find some blank space. 2 plus 4 over x minus 2 equals 8 over x squared minus 2x. Again, what makes this a fundamentally different thing than all of the stuff we've been looking at the last 3 classes? It's an equals, right? That is an equation. It's just different. Okay, so just like before, we're going to make the lowest common denominator. And just like before, we're going to do that by putting fraction lines that are kind of long because we're going to end up completing the denominators to make them all the same. So all I've done is taken my first 2 terms and I gave the 2 a fraction line equals. And then the other thing that we would do in our first step is factor those denominators. What can you factor out of x squared minus 2x? X, so we'll pull x out. What's left? X minus 2. That's good. So that's our first step. It's exactly the same as it's been in the last 2 classes of adding and subtracting when we're trying to make a common denominator, right? We would just write our fractions with big fraction lines, factor those denominators. If you really don't like the 2 having no denominator, you can put a 1 there. I'm not going to put it. Okay, now the goal is to make all these denominators the same. We're going to complete them by filling in what's missing. We've been doing this the last 2 classes. Let's make the first 2 denominators the same. What does this first guy need that the second one has? X minus 2, the whole thing. So I'm just going to put x minus 2 and therefore the top by x minus 2. And this is the part where I say, oh yeah, I need to put parentheses around all those numerators. So we'll just put them all in. And the second denominator already has the entire first denominator. So these first 2 denominators are the same. So far, so good. So now we bring the third denominator into the mix. What do the first 2 denominators need that the third one has? They need an x. Do they need an x minus 2? No, they've already got the x minus 2. Quite common to have this overlap in these problems. So they both need an x. So let's give both of them an x, which actually means we need to put parentheses in this denominator here, which we didn't have to before. So we gave that denominator x on top and bottom. We're going to give the second denominator an x on top and bottom, which means it needs parentheses it didn't have before. And then what do we see about the 3 denominators? They're all the same. Perfect. We have built the lowest common denominator. All 3 denominators are exactly the same. Okay. So here is the twist. This has been the same process as been the last 2 classes for us. The next step in our process is to multiply both sides of this equation by the right thing. And as long as we multiply both sides by the same thing, we're doing legal things, right? We multiply both sides by 7. As long as it's the same thing on both sides, we're okay. We're going to multiply both sides by that lowest common denominator. We're going to multiply this side by x and x minus 2, the denominator. And we're going to multiply the whole left-hand side. I'm going to try to squeeze it in up here by x, x minus 2. Both sides by the lowest common denominator. Okay, and that's legal because we did the same thing to both sides. On the right-hand side, something really nice happens. What are we doing here? Let's go back. This x and x minus 2, if you have trouble seeing whether it's top and bottom, it's firmly on top, right? Put a 1 under it if you want. So then what happens with the x up here and the x down there? They cancel, and the x minus 2 and the x minus 2 cancel. And all of a sudden, the right-hand side is simply 8, not a fraction anymore. And something nice happens on the left-hand side as well. It's a little bit harder to see. I'm going to just do a lot of pointing, but we're not going to write a lot. There is a plus sign in the middle here. And so this is a big distributive property on the left-hand side. We buy that? All of this is going to come in and it's going to hit this first fraction and it's going to hit the second fraction, distributing in. Yes? We're just going to imagine that happening in our minds. I'm not going to write it all out. When this thing distributes to the first fraction, I'm going to have an x and an x minus 2 on the top and an x and an x minus 2 on the bottom. And what happens with them? They cancel. That cancels on the first fraction, but it is still in play on the second fraction because it distributes before it does anything. And so now I'm imagining this guy next to the second fraction as well, and it is still on top. And so what happens with this guy on the top here and this stuff on the bottom? They all cancel. You see that? The x and the x minus 2 would appear twice. It's going to be on each fraction, and it's just going to entirely cancel all those denominators. So I don't quite know how to write it. I mean, I'll cross this. Oops, let's go another color here. I'll cross this thing off, but it actually crosses off twice here because it distributes into the two fractions before it cancels anything. And so all that we're left with is what was up on top. So I've got a 2, x minus 2, x plus 4x. Any questions on that? The key is that multiplying both sides by that lowest common denominator gets rid of all the denominators. And of the 3 equations that are up on the board right now, this last one is by far the friendliest, right? There's no fractions anymore. This is an equation I could have asked you to solve weeks ago when we were solving quadratic equations. So let's finish, but there isn't anything new from this point onward. It's going to be fairly straightforward. I'm going to collect the 2 and the x in my mind and distribute it through the parentheses. So that gives me a 2x squared minus 4x. Okay, 2x distributing through. Plus, there's a 4x there, equals the 8. 4x is canceled. So we get 2x squared equals 8. You got 2 choices here. You can either get one side to what magic number? What's the magic number for our quadratic equations usually? We want a 0 on one side, right? Get everything equal to 0, and then we can use one of a number of tools that we have. Or because this guy doesn't have an x term, you could actually use that square root property at one point, but not yet. What do we need to do first before we take the square root of both sides? Is divide by 2. We got to get that 2 out of the way first. So that is my preference, but I'll write both. I would say divide by 2, and then take the square root of both sides. So we get x equals 2. Is that right? Or negative 2. It's so, like, this is my preference, but it's so easy to forget to put in that plus or minus. When you take the square root, you got to put in the plus or minus. So even though I think that's the simplest way to solve, honestly, it might be safer to go the equals 0 route. Then you don't have to worry about remembering that plus or minus. So 2x squared minus 8 equals 0. What can you factor out of both? 2 comes out, leaving x squared minus 4. But x squared minus 4 is a difference of 2 squares, right? We've seen that pattern before. Right, x plus 2, x minus 2 in some order. And then either x plus 2 is 0, or x minus 2 is 0, or I guess if we're really being complete, 2 equals 0, setting each piece equal to 0. First equation has no solutions. The second equation, you get x equals negative 2 by subtracting 2. Last equation gives x equals 2. So we do get our plus or minus 2 without having to worry about remembering to put in that plus or minus symbol. Any questions on that? With the plus minus? You're right. If that had been like 2x squared minus 9 or 10 or 11 or anything that didn't give the perfect square, then you're right. We wouldn't be able to do this. So I think the first one is easier, just a lot less work, but it's so easy to miss the plus or minus that I almost tend to push people the other way. But you're right, it's a weakness of the other way. Okay, so the only other new thing for solving equations with algebraic fractions in them is that I said the check is mandatory. And I really haven't been harping on doing the check all semester, but I am here in this section, and there's a real good reason for that. Let's consider the x equals negative 2. I'm going to go back up here, and let's check x equals negative 2. So you don't have to write the whole thing down here. You'll get what we're after without writing it. We're going to plug negative 2 every place we see an x and see if the equation works, right? So 2 plus 4 over x becomes negative 2. Then there's another subtract 2 there. Equals, I'm going to put a question mark because I don't know yet, 8 over negative 2 squared minus 2 times negative 2. Everybody see that? Just change all the x's to negative 2's. Okay, so this guy becomes 2 plus 4 over negative 4 equals maybe 8 over, let's see, what do we get down here? That's 4, and then it becomes plus 4, right? Okay, so did it work? Let's see. That's a 4 over negative 4 is negative 1 equals maybe 8 over 8. Does it? Just change color there. It does, right? 1 equals 1. Okay, super. So x equals negative 2 works. Doesn't seem very interesting. Let's plug x equals 2 in. What happens when you plug x equals 2? The denominator is 0. Well, that's surprising and also problematic. That's enough of a problem, but let's just check and see what happens here when you plug x equals 2 in. It's also a 0, right? 2 things undefined. Even 1 would be enough to say, hey, x equals 2 didn't work. Right? You get something undefined, you don't have a solution. And so the reason you got to do this check is even though we did all good math here, we didn't make any mistakes, we still ended up with a solution that wasn't really a solution. We didn't do anything wrong. This is just the nature of equations where x's are in the denominators, is that you can get these guys, I think the fancy word is extraneous, like extra. They appear to be solutions, but actually aren't solutions. So x equals 2 gets rejected. And so that means x equals negative 2 is the only solution to this. Okay, and the last thing I'll say about this is that even though the check is mandatory, I'm going to give you a shortcut right now. You don't actually have to do the entire check like we did at the top of this page and get as far as you need to before you say, oh yeah, 1 equals 1, that's a valid solution. You don't need to go all the way through. All you need to do is check whether or not you end up with a division by 0. As soon as I plugged my negative 2 into these denominators and I saw I didn't get any zeros, that's enough to know it's going to work. It's going to be a solution. And as soon as you plug in x equals 2 and see a 0 in the denominator, you stop and say this is not a solution. Okay? So you don't need to go through the entire check. You just need to make sure that you're not dividing by 0. Any questions on those? Okay, activity starts on the next page. Let's see how far we can get.